In this video, we're going to take a look at Socket.io and WebSocket technologies and learn how to use Fiddler Everywhere to troubleshoot issues with those. Fiddler Everywhere is very powerful. When you start it up, you're going to start seeing a lot of background conversations using HTTPS to communicate with a whole host of other services or servers. So one of the first things we're going to want to do is we want to tame that list of things that are being traced, and we'll do that taking advantage of a feature called filters. So here's what the filters look like, and you'll notice I have some particular hosts that I'm going to use just for this video. So I wanted to make sure that those were the only thing being captured. So I know the host names. So this rule just says if any of these conditions is met, and it just lists out the various hosts. Otherwise, when you start Fiddler Everywhere, there'd be so much other traffic coming in, it's hard to focus on what you want. So I know where I'm going to go during this video, so that was the first step, is set up the filters. So I'm only seeing traffic going from the client to those hosts. It's really helpful that in Fiddler Everywhere, I have a message immediately that I have a filter active. That way, if I don't remember that that is there and I want to go look at other hosts, I would not be seeing that traffic and I would wonder why. So on this, I can either click on Disable Active Filter, or I can click the drop down and see I can disable there as well. I also have the ability to save filters. So I have a number of different filters for different situations, so I can keep those between sessions with Fiddler Everywhere, come back and apply the same set of filters. The web started as a technology and protocol where the client would enter a URL, hit enter, it would go to the server, pull down the HTML, parse it, and start downloading additional things like images, CSS, JavaScript. Most people probably start using Fiddler Everywhere to get traces of these types of website, where the client is going to the server in a request response. So the client is always initiating conversation to the server and waiting for an answer. We'll use this fictional travel site as an example for how normal case client request response works. We're simply going to hit enter. We see the page appear. Let's go back to Fiddler Everywhere and see what that looks like. So this is a very classic request response model where we make the initial request to the server. We can see that there is a request for a certain page along with headers and other information about the request. And we'll see the response that came back from the server. So what we see on the left-hand side is once the HTML comes to the client is parsing up the HTML and then making requests for images, JavaScript, CSS files. But again, the client is making individual requests and getting responses back from the servers. It's always driven by the client initiating that conversation. There are, however, a whole class of applications where the server side would like to be able to send information to the client. The normal HTTP protocol that just wasn't designed for that. Things like chat or stock tickers, or I'll show you a little later, a bingo game. Times when the server has information it needs to send out to clients, changes that model, and we'll look at how that problem is solved. The first solution we're going to take a look at is called WebSockets. The idea with this is a client will send to a server and say, I'd like to create a WebSocket connection between the two of us. And what that means is essentially there's a pipe that's kept open between the client and the server, and it's called bidirectional because either side can initiate a conversation. We understand there are use cases where the server would have information it wants to push down to the client. We'll take a look at a very basic WebSocket. One of the typical types of applications to demo WebSockets is an echo service. Code on the client where it's just opening a new WebSocket to a specific server. And then there's a series of different events that can occur. The first one would be as that connection's finished, we're going to look at a handshake that happens within Fiddler Everywhere. Then we'll see a connection established, so that event will fire. The client now knows there's an open WebSocket, so it's going to send a message. Rather than looking like normal AJAX calls or HTTP client-initiated calls, where they would wait for the response to come back. Here the client just says, I sent something, and it goes back to just seeing what other events occur. With an echo service, the server is going to actually just echo back what the client sent, and it'll fire the event to be able to read that data. And when either side is ready to be done, they'll do a close, and you can see the event that somebody closed and will show that event data. Again, as a small example, we're on the client here. As we run that page, we'll notice some of the event. There was a WebSocket connection open between the client and that server. We'll then see that the client saw the open connection, so it sent hello world to the server. The server in the meantime has been pushing things back. So it first says it received something and what server it was coming from, and then the server just reflected that value back to the client. Let's see how things are working in Fiddler Everywhere for this situation. So the first request we'll see is just a normal HTML, HTTP, where the browser went to a page, the page came down, and then it's going to start doing its WebSocket connection. Both HTTP and WebSockets are connection-oriented protocols, so they both sit on TCP in the TCP IP stack. The way a WebSocket connection starts, the client is first going to send an HTTP request, and we'll see in the request that it says it wants to upgrade a connection. We'll see that it wants to use WebSockets and what version it supports. Then we'll see the server is responding and saying, 101, let's switch protocols. We're fine with going from being HTTP. Let's instead talk over WebSockets, and it sends some more information back. And then the connection is established, and that's what we see in the handshake. Next, we can look at the messages. So these are the specific things that were sent back and forth during this conversation. So instead of having the normal things we see on the left-hand side, where each message in a normal Fiddler Everywhere trace for JavaScript CSS has its own request on the left side, this is all now using a WebSocket. And we're going to go on the right-hand side and see the individual messages. So a connection was established using the HTTP we noticed. The client had sent and made a request for that connection to be opened. The server is responding to that open connection just by saying, this request is being served by, and some indicator for which server that was. Then we see the client sends up its message saying hello world. And because this is an echo service, we can see that the server sent the same thing back to the client. So this is a typical WebSocket, and again, communication can be initiated by either side, as we see the server first push which server it was using, and then later on pushed out the hello world to be an echo. Next, we're going to look at an example on Mozilla's site about a JavaScript client talking to a C#. So I'm an ASP.NET C# developer. I'm going to implement the WebSockets server side based on that, just so you can see how that looks. Again, the client will look very familiar to what we had before. It's going to create a connection. In this case, 127.0.0.1 is this machine on port 6970. So I'm going to set up a server instance running on this machine at that port. You'll see the client does the normal WebSocket, and then down below we have the same kind of events that are capturing things that are happening over that connection, whether it's sending something to the server or the server happened to push something down. So the rest of that should look really familiar. The server-side C#, we can see again the IP address for this machine, the port that we chose to communicate over, the fact that it's using a TCP listener. So again, WebSockets is sitting on top of TCP, the connection-oriented protocol. This will look like a typical server implementation. It doesn't accept TCP client, so when the client connects, it'll fire that event. Down below, we're just doing an infinite loop, so the server's just going to continually listen for connections, receive something from the client, do some processing, send a response back. A lot of the handshake details you can see in this C# code. There are very specific ways to use the incoming header that has a key and doing some hashing and such to prove, essentially not so much for the security of it, but to make sure that both of the two sides are confident they're talking over WebSockets because each of them is following this progression. Here's the client for that. We'll just send another message of hello world. We can see the handshaking. We can see that it had WebSocket rocks and hello world. It's not sending anything back in this case. It's just showing how that would be received by the C# server. Of course, we'll take a look at what this looks like within Fiddler Everywhere. We can first see the request to get the HTML page with the JavaScript basically for the client. And then again, we can see on the left-hand side the indicator that this is a WebSocket. If we look on the right for that request, we can check the handshake, and we'll see the two things we've seen before where it's sending over HTTP, just saying, I'd like to use WebSockets, are you cool with that? And then the server and client will start sending some messages back and forth. And in this case, the client sent both of these two messages to the server, which you saw displayed in the console. For the last WebSockets demo we're going to see, this is going to be C# on both the client and the server. This is the client code using built-in WebSocket support in .NET. Pretty straightforward as far as making its connection, eventually getting where it's waiting to receive something from the server. It captures that information and displays it. So this is a game of bingo if you've played before with the board that has numbers between 1 and 75. And each client would connect to the bingo server. And then the server is going to keep running the game, picking another bingo ball, and wants to then send it and push it out to all the clients. So this is a good showcase for WebSockets. If we look at what the server looks like, here it's mapping a particular URL, so it has the local host and port. And if you go to that/WebSocket, the server is just going to accept that connection, go into an infinite loop, and then start asking for bingo balls, and then lower, it will do a sleep for 5 seconds. So let's see how this looks within Fiddler Everywhere. So the C# client opened up a WebSocket. Again, if we look at that on the right-hand side, we can first go through the typical handshake that occurs, where we'll see asking to do an upgrade, again, switching protocols, so now the socket is established. We can see each of the bingo balls being sent from the server 074, I23, G48, and etc. So every 5 seconds, the server's getting a new bingo ball and then pushing it out to the clients. Another good option for bidirectional communication between the client and the server is Socket.io. Socket.io is not an implementation of WebSockets. So if you have a WebSocket client, can't talk to a Socket.io and vice versa. It's actually Socket.io is a streamlined bidirectional, and it's going to use one of two methods for communication, either long polling or the WebSockets we looked at previously. So Socket.io just adds a lot of features on top of one of those two transports. Ideally, it's using WebSockets. Nowadays, most of the browser clients support using WebSockets. When this library first came out, one of the main reasons people wanted it was the ability to have that fallback. In other words, use WebSockets if you can, otherwise fall back and do long polling. We're going to take a look here at the server. So we're implementing the server here using Node.js, importing the necessary packages, and then it creates a server and listens on port 3000. You'll see very similar event handlers for various portions of the communication. So when a connection is made, when a message is received, we're going to start up the server process by typing node and then index.js. You'll see that it shows now the server is indeed running on localhost on port 3000. Now let's take a look at a Socket.io client. This is written in JavaScript, a typical HTML page with some CSS at the top. We have a form where we're going to enter information we want to send to the server. We'll see that we're including the socket.io.js. We're creating the socket, and then we're setting up some event handlers for when we hit submit that will transmit the information to the server. and then one when we actually receive messages back from the server when it chooses to send. Let's take a look what this looks like. This is the client web page we just reviewed, and we'll see that it is indeed connecting to localhost on port 3000. I can enter the input box for the form and start to send some messages again. So we'll try our hello world and hit send. And then we'll see what happens on the server. So you can see here that a couple different clients have connected and it has received that message for hello world. Let's take a look at what it looks like in Fiddler Everywhere. In Fiddler Everywhere, we can see the first request for the actual HTML page and for the JavaScript. And then we'll look and see that it's trying to start out using polling. So it wants to start with long polling just in case it did not support WebSockets. So we can say first it's attempting to make a connection and it says it wants to do polling, which we can see here. Eventually it gets to the point where it says it wants to transition. Now it wants to use WebSockets. So if we see here, similar to what we've seen before, we'll have the typical handshake going back and forth and switching protocols. But when we go look at messages, we'll start to see that there's more information we are getting from the socket IO in this case. So if you see here, there's some pings and pongs. So that's part of socket IO. And what it's trying to do is it wants to make sure that that connection is still open. So you have a client and a server, you have a WebSocket, it's periodically sending out a ping, and then it has to be a corresponding pong. If either side doesn't see that within a certain amount of time, then they feel that connection is not open anymore, and they'll switch and go back to trying to do polling. So let's look at a few of these. As we said, here's the ping coming from the client, and the server responded with the pong. And then we see some of the messages go back and forth. The hello world was transmitted from the client and sent back from the server. We're not displaying it. So there are other things built into Socket IO to deal with reliability, disconnects, all those sorts of features. And it's nice that Fiddler Everywhere gives us more specific information in the case when it's looking at Socket IO running basically using long polling or WebSockets. I'm going to focus a little more on each one of the polling and the straight WebSockets. Again, the way Socket IO works, it starts out using the long polling. Once it's gone for a few communications, it then tries to establish a WebSocket, and it basically will use the WebSocket if they do, otherwise they've still got the polling set up and running. So I just wanted to set that I only want to use polling just so we can see what that looks like in Fiddler Everywhere. We're going to look at what happens now that the client only wanted to use polling. We'll see the normal requests for the web page. We can see the request for the Socket IO JavaScript. And then if you look down the left-hand side, there are no WebSockets created in this case because the client said it only wanted to use polling. So the way the polling works, the client will do a GET request to the server. So in this case, it's sent to the server and says that it wants to do polling, and the server responds below saying, I can use WebSockets as an upgrade if you'd like. The client is going to stick with what it wanted originally using polling. It does a GET. In this case, the server needs to send something back, so it comes back. And then what we'll start to see as we go through, this is a post. So when the client wants to call the server and let it wait, it will do a GET request. When the client specifically wants to tell the server something, it does it via a post. So in this case, it's a post. It's telling the server that we're okay, we're good to go. Then you'll see a GET request. So again, here it did a GET request. The server will keep that connection open as long as necessary until the next bingo ball is available. Then it will use the response of this GET request to basically push that message down to the client. And we'll see the same thing as we go here. They're just GETs. Those are held open. Then the server eventually wants to be able to respond, so it will respond to a pending GET request, and then it will continue again. The next case we'll look at is forcing use of only the WebSocket. We'll see what this looks like behavior-wise. So we can say the behavior that we're used to, or about every 5 seconds or so, we're going to see a new bingo ball that was generated on the server to get pushed down to the client. Let's see what this looks like in Fiddler Everywhere. So in this case, you see the HTML request, the request for the JavaScript. Previously, you saw Socket.io would first try to start out using polling. So there'd be a number of messages going back and forth about polling, and then it would later attempt to use a WebSocket. This is just a lot more efficient. If I know that I support it in my environment for all the clients, I can just force it to use WebSockets and avoid that kind of introductory communication that it would have landed on WebSockets eventually anyways. And if we look here, we'll see the handshake. So there's the normal handshake we expect, doing a get, doing a one-on-one, switching protocols. Then we'll go back to messages, and we'll see the typical things we've seen before. G58, G52. So here's just the bingo balls coming down. And again, we'll see ping and pong. So the idea with this is you can, on the client, advertise you only want to use WebSockets if you want to gain that efficiency. And you can just see the different traces and how Fiddler is showing us how the client and server are communicating. The last thing I want to show is the inspectors that let you look at the data that's going back and forth on the WebSocket split up at the appropriate layer. So here we can see we have a message. From a Socket.io standpoint, it's just the B9. When we look at the message pack, we can see part of the WebSockets, that bingo message is being sent WebSocket-wise, and the client knows what type of message that is. So when you look at this, you can see a little bit more. You can also see if you want the hex version, JSON version, or the straight-up text. So again, if all I care about is the Socket.io level and the messages I'm sending, I can look here. If I want to get more detail about all the other things that happen as this gets transported, I can see them at these other levels as well. So with that, we've reached the end of the video. I hope that you've seen some interesting ways to troubleshoot if you're using technologies like polling, WebSockets, or Socket.io, and how Fiddler Everywhere makes that much simpler. Thanks.